Hello and welcome to Guided Notes with Mr. Weeb. Today we are looking at the area of a parallelogram. The goal is for you to be able to say, I can use properties of a parallelogram to create a formula for calculating the area of a parallelogram. Let's get to our first page. You can use the base and height measurements of a parallelogram to figure out its area. And so here, we should label this as the base. So this is the base, and this line right here, from here to here, that is the height. So it's not this line, this is not the height. This line right here is the height. Any side of the parallelogram can be the base if the right height is used with it. So let's write height in that blank. So in this case, the base is right here, and the height is actually this line right here. That is the height. It just depends on which side you want to go with. A parallelogram, let's look at these key terms. A parallelogram is a quadrilateral that has two pairs of parallel, good name for it, a parallelogram, has parallel and equal sides. The area is the amount of space in a two-dimensional shape, the number of two-dimensional units that cover this space. So you're looking at how much stuff is inside here. That's what the area is. The base of a polygon is usually any side of a polygon. The height of the polygon is measured from the side that is called the base. And the height of the polygon, it's the distance from the base of a shape to the opposite side or vertex of the shape. The height forms a right angle with the base. And in this notation here, this right here, this angle is a 90-degree angle, or called a right angle. Same thing here. Here's a 90-degree angle. And a right angle is an angle. It's an angle that measures 90 degrees. Let's continue on to the next slide, where it says, a formula lets you figure out the area of a parallelogram more easily than counting squares on a grid. Let's write in counting. For a parallelogram, area equals base times height. And if you want to be a little bit simpler with it, you can say area equals base times height, where this, in this case, we'll call this the base, and we'll call this the height. Remember, we're not calling this the height. This is not the height. Okay, and in this case, the area here is going to be just counting how far this is. So we've got 1, 2, 3, 4, 5, 6, 7, 8. The base is 8. And the height is 3. That means that the area is 24 units squared. Most often we won't do units, we'll do centimeters or meters or something that we often use, but since this, we don't know that it's a centimeter, we don't know that it's a millimeter, we'll just call it square units. And that's because these units are all in squares. They're little tiny squares. How many of these little squares fit inside this area, inside this two-dimensional shape? All right, and if you know the area of a parallelogram, you can figure out what the base and height might be. For example, if the area is, let's say that the area is 12 units squared, and we have a base and we have a height, well, we can find several different possible solutions to this, right? We could say that the area might be, the base might be 6, and the height might be 2, because 6 times 2 is 12. The area could be 3, and the height could be 4, because that would make 12 units squared. And it could be 1 times 12, right? The area could be, now that's not likely because the base looks much longer than the height in this picture, but it's a possibility. It's a possible answer. That's it for today. Thanks for watching.